Hello everyone, my name is Zahik Ibrahim and this video is to demonstrate the assembler and programmer which I have built for this microcomputer. We have built this microcomputer for our final year project of MCA, and on top of it I have built this assembler and programmer for the memory, so we do not have to write instructions manually using the switches on the computer. So let me start with the overall architecture of this assembler programmer. So firstly, there is a web client where we will write our program in assembly language. For example, we wrote an instruction add 15, and through the HTTP protocol, it will go to the Spring Boot application which I have created. So this add 15 will go to the Spring Boot application through HTTP protocol. So what Spring Boot application does, it receives the instruction in assembly, which is, for example, there is add 15, and to add, it will give its respective opcode, which is in binary, and for 15, it will just convert it into the binary format. And through UART protocol, it will go to the Raspberry Pi Pico, which we have installed. And on that Raspberry Pi Pico, we have a basic firmware which just receives these binary instructions, and according to the instruction, if it is the first instruction, the address will be set to 0 by the Pico itself, and then this instruction will be set on the uh, RAM which is on our computer. So on the specific address, the specific instruction will be written. So this is the web client which I have built to write the instructions. So if we launch this, and here is the interface. We have the instruction set of our computer over here, which is custom, and we can write instructions over here. For example, we can write the instruction. It has to be all caps, and then we write the address. If it is add 15, it means add whatever is in the 15 address. So if at the 15 address, we go to, these are addresses. So if we go to 15, and we write 20 over here, so it will add 20 to the A register, whatever is present in the A register. So now let's write some meaningful program. So now we have wrote this program over here. Let me go through it quickly and tell you what it does. So firstly, it's out. So whatever is in the A register, it will output this. Then add 15. Whatever is in the 15 address, add it to the A register. So at 15 we have 1. So then check if the carry flag is set. If the carry flag is set, then it will jump to the 4 address, which is subtract over here. And if the carry flag is not set, then it will not jump and go to the third instruction, third address over here. It is jump to 0. So no matter what happens, if this instruction is executed, it will jump back to 0. So same way, it will add till we reach 255, and at the 256th we will set the carry flag, and the instruction will jump to subtract, and it will keep on subtracting until the 0 we reach at 0 and the 0 flag is set. And when the 0 flag is set, we jump back to the 0 address. So same way, this will just count to 255, then it will start subtracting and then subtract till 0, and it will continue in this loop forever. So this is the programmer, and this is the Raspberry Pi Pico, and it's connected to the address lines of the memory and the data lines of the memory. Then read, then program mode and run mode, as well as the write button over here. So it's connected through this USB cable, and this USB cable will go in my USB port of my laptop. So now it's connected, and now we can run the program on the computer. And it failed. So that's because I left these spaces empty. I cannot leave those empty. I have to put 0 on each address. So now if I click upload, the program uploaded successfully, and if we go back to our Spring Boot application, we can see our program over here. Then it converted to the opcode and the binary of the address or data, whatever it was. Then it formatted in this way, and through USB, it sent it to Raspberry Pi Pico. On Raspberry Pi Pico, there is this simple C++ firmware which receives all the instructions in binary, and according to those instructions it sets those data lines and sets those address lines through GPIO pins and writes those instructions. So now as soon as I click upload over here, we can see the Raspberry Pi programming the each address of the RAM, and its the addresses are being set, and at that address the specific instruction is being set. So now the program is in our memory, and if I run the clock, we can see the program is being executed, fetched into the instruction register, and we can see the output over here. It's counting. And if I increase the clock speed, you can see it running faster. And as soon as it will get to 255, the carry flag will be set and it will start subtracting 1. Then it will go back to the 0. So the carry flag was set and now it's counting down to 0. And when it will reach the 0 flag will be set. Then they both will be clear, and this will be starting again from the 1, 2, 3, 4, 5 till 255. That concludes our demonstration of this assembler for this 8-bit microcomputer. So if you want to dive deeper and know more about this project, you can contact me on LinkedIn. I will give my LinkedIn in the description. And if you want to look at the code, it's on my GitHub, which I will link down in the description as well. And if you would like me to make a more detailed video on this assembler on or on the computer itself, you can tell me in the comments and I will make it. Thank you for watching, and feel free to contact me on my LinkedIn or on my GitHub.